Alright guys, I'm going to talk about Firestarter 1 and Firestarter 2 today. So it says if you need to use Google or any other method, look it up. You can totally do that. Um, this isn't like a easy question to just look up. You'll get a lot of different information. So sometimes you guys will struggle with this because you have to look it up and then you have to like think about what you look up. So you can look it up. For us, we're going to deal with a lot of stuff, and like what's always going to start usually, and this is going to hopefully make some sense, is usually the first reason you're always going to hope for is given. All right? Given is going to happen all the time. Um, that's the easiest one. You can't argue with it. So the given can be in words or it can be in the figure. Now remember, if it's in the figure, it has to have those markings on there that was already there, not the markings that you would have added. That's like the dashes to say congruent sides. So specifically, when we talk about a figure, we talk about, the dashes, right? So like, that's our first thing. Why else might um, some sides be congruent? Well, you could have. I think this is going to be a little bit different, but it's called the reflexive property. And the best way for me to explain that is I call it a shared side. If two triangles have the same side, then those two sides have to be congruent because it's the same side. It's like looking in a mirror. When you look at the mirror, you see yourself. You don't see something else. So reflexive property happens a lot. You'll see something like this, and this is just a fancy way for me to write definition. So that's definition of midpoint. Sometimes you'll say like blah 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 is the midpoint of blah blah blah. So maybe you'll say like B is the midpoint of AC. Well, that means the two chunks. So if I have AC, and that's a really good spot for that. If I have AC, I could say B is the midpoint. Well, by definition of midpoint, I could say those two are congruent. And the little red mark, that would be what I'm talking about when I talk about a dash. If that was already in the picture, I wouldn't have to say that. If the red little dash, if this red dash right here was already in the picture before I did any work, then that's a given. But if it wasn't there and I put it there because in the statement was B is the midpoint of AC, then I would add the dashes and I would say that's the reasoning. So remember, everything's got to have an argument. The other thing you might see is definition of segment bisector. So that's another one. And it's very similar. Like if you say B is a bisects AC, or a line, maybe BC or BD segment bisects. If you see the word bisect, usually that means cut into two equal pieces. So all those are, and there's more, guys. There's way more than this. This is just a couple you're going to see a lot of. There's going to be more than that, right? So list of possible reasons for why angles might be congruent. Now there's a lot more for angles as well. So once again, with angles, given, we're always going to hope for given, right? Remember, same thing, words, maybe it says angle blah 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 is congruent to angle blah blah blah, or in the figure, and that's where you would see arcs. So words or figure. You could even have the reflexive property again, if that's a little bit harder to see in angles, but it's definitely possible. Like you could have two triangles that's called a shared angle. All right. What else could we have? Well, we could, if you see two parallel lines cut by a transversal, we have all those theorems we learned in all those properties, like alternate interior angles, corresponding angles, alternate exterior angles, right? All that. Now, the other thing you might see, guys, is you might see like definition of angle bisector. So like if you see an angle is, or something bisects an angle, that's going to be something you use that. Right? And these are just guides. These are not all of them. There's so many different theorems and properties out there. This is just a good guide. It's just a good way to kind of start. All right. That's it for Firestarter 1. All right, so now we're going to do a proof. So the idea that we hopefully figured out was that some of the stuff you looked up on Firestarter 1, you're going to use in Firestarter 2 in the worksheet, the white worksheet, the yellow worksheet, the pink worksheet. I gave you 3 worksheets before you left, so I will make those as assignments, and we'll go from there. So statements and reasons. So guys, whenever you write proofs, you always must start with statements and reasons. All right, you have to put statements and reasons. Remember, guys, proofs kind of like going to court. It's got to be legible, look good. Everything, all your evidence has to be in order. Basically, think of it as you are a prosecuting attorney. You need to prove beyond a reasonable doubt that the statements you're going to making are true. You cannot just guess at a proof. That is not how proofs work. So I always start with given information. This is given because it was written on the paper for you. So they gave that to you. So the first thing I'm going to do is I'm going to say IS, right? It's got to have the bar over because we're going to say congruent. So segment IS is congruent to RQ. All right. This is given because it was presented to you. It was there. All right. You can, if you want, add the dash, IS, RQ. If the dash is already there, the red dash on IS, so if this dash was here, but that wasn't written there, as long as the dash was written by me or was presented in the original problem, that is also a given statement where you would have to write it out yourself. Now, we see another given, IR, is congruent to segment SQ. So that's a given. Because of that, I get to put that here. So I like to add the I had to create the figure if it wasn't there. If this figure wasn't here, the first thing I would do was draw a couple triangles. I might not draw it like this, but I would draw at least 2 triangles out, and I would put these dashes in here. Now, the reason for both of these is given because the original problem tells you it. You don't have to think about it. You have to argue about it. It's there. All right. Today's keyword is the law. Today's keyword is the law. Now, luckily, guys, I know that, and it's because I told you ahead of time, I told you that we are going to be using side, side, side. I'm not always going to tell you what method we're going to use, but when we were first learning this, kind of like training wheels, I'm going to tell you what method we're going to use. So I know that I have to have 3 side statements. So this first statement is talking about sides. The second statement is talking about sides, right? And the figure is going to be important because location matters when we start using sides and angles together. It would matter where your angle is placed between these sides or next to these sides or so forth, so forth. But I know that somehow I need to get this side right here. So the next thing I need to think about to hopefully make this see a little bit easier is I'm going to call this bottom triangle the blue triangle. And I'm going to call this top triangle the green triangle. And hopefully you guys can see that this line, or this segment, I don't know why I said line, it's terrible. This segment, SR, it is blue and green. We call that a shared side. So SR is part of the top triangle, ISR, and it's part of the top, or the bottom triangle, QRS. So I get to say this, believe it or not. I get to say SR segment, you got to have the bar on top, is congruent to, sometimes they write it RS. I always just write it the same. It doesn't really matter to me. Some people will be picky and say SR is congruent to RS based on correspondence of the triangle. It's a little complicated for you guys, so however you want to do it is fine by me. And that's a side. And the reason for that, it's not given. You didn't get to just look at the problem and see that. You had to look at the problem and remember that they have a shared side, and there's a property, and that property is called the reflexive property. So anytime you have a shared side or angle, that's going to be usually going to be used a reflexive property because it's kind of like looking in the mirror. Right? Now I have one side, second side, third side. That's going to tell me that I have a congruent triangle. So here's how you always write it. So every proof of yours will, at least to start, will end with this. So I'm going to say triangle. So you have to have the triangle symbol. I'm going to say I, then S, then R. It's really important that I understand the order there. So I say I, then S, then R. So I went I, which is on the corner of 1 dash and 2 dashes. And really, we could add 3 dashes here. S is on the corner of 1 dash and 3 dashes, and R is on the corner of 2 dashes and 3 dashes. I talk about that corner because I need to make sure I write it in the same exact order comparatively. What that means is I have to say, look, I started at Q here because it's at the corner of 1 dash and 2 dashes. So correspondence-wise, I corresponds with Q, right? They're both at this same intersection, respected to one another. So those points have to be in the same order. So I have to start with triangle, because we're talking about a triangle, Q. Now, I started here, and I went from 1 dash to 2 dash down to the corner of 1 dash and 3 dash. So I'm going to go down to R, and then I'm going to go over to S. You will lose points if this is not the correct correspondence. All right, so it's really important. We talked about that in our last quiz. Now, the reason for that is going to be side, side, side. And that's it. It's called you don't have to write out the whole thing. You could say side, 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 triangle congruence theorem. We're just going to put SSS. And that's it. We're done. All right? So every one of our proofs, especially in the white paper, will end with triangle something, congruent to triangle something. It'll end with side, side, side. Like I said, I usually write SSS. It will always have 3 side statements. There could be more. It doesn't mean it's only going to have 3, but it's going to have at least 3. There could be some geometry concepts in between that lets you kind of get to those paths. It will always start with statements and reasons. It will always begin with the given. So that's all stuff you need to kind of think about when you do your side, side, side worksheet. So we're going to have our side, side, side worksheet due when we come back to in-person instruction. All right? Thanks, guys.